here are two parabolas. We're looking at two parabolas. Y equals x squared is our parent function. And we talked a lot about that in chapter 2, is our parent function. So it is in red. This is our parent function. And we can do all sorts of things with that parent function. Okay? Now, the second one in blue is what you have probably been told is standard form of a quadratic. Okay? So you've been told that's standard form of a quadratic. And I actually believe it is standard form of a quadratic. Our book doesn't call it anything. Okay? Now, look at the green one. Now, I will tell you that the blue graph and the green graph are on top of each other. So you're only seeing the blue one. But they're both on top of each other. So the blue graph and the green graph are the same parabola. Exactly the same. Okay? Now, look at the green equation, and what can you tell me about that? The green equation. Think about translations, shifts, movement of the vertex. What does that look like right there? Okay. What about the 16? That's exactly right. That's exactly right. Okay, so our parent function, which is x squared, for the green graph, it moves left moves left 5 and up 16. Okay, so here we have our up and down, and it's true to value. Here we have our left to right, and it's opposite in value. Okay, that's a translation. That's a translation. So this one right here, it moved 5 units to the left, and it moved 16 units up. Okay, what is this point right here called on our parent function? What's that called? Anybody? It's our vertex. It's our vertex. Okay? That's what moves. So when I move 5 to the left and I move up 16, what I'm talking about that's moved is my vertex. My vertex is what's moved. My vertex in the red is 0, 0. My vertex in the green is -5, +16. So my vertex, we can identify what my vertex is from this formula right here, or this form that also tells us how our parabola moves. Okay? We can identify our vertex. Okay? From this situation right here, we can identify our vertex. And that's what we're going to be focusing on, is what do we do with that information? What do we do with that information? How do we move that? How do we get it into this form? Once it's in this form, what do we do with it? Okay? That's what we're going to talk about today, and it's what we'll finish talking about on Tuesday. Okay? Can I go to the next screen? I love it. We good? Awesome. Okay. Now, I was always taught, and if you had me for 131, you heard the terminology that ax squared plus bx plus c is the standard form of a quadratic. Okay? ax squared plus bx plus c, that's what you have to have it in before you can factor. That's what you have to have it in before you can use the quadratic formula. That's what you have to have it in before you can complete the square. Okay? That is, and it's probably what you were taught in high school is the standard form of a quadratic. Okay? Today, we're going to focus on something called the vertex form. The vertex form. Now, I do not know why, but our book calls this standard form. Okay? Now, when I give you a test or when I give you a quiz, I'm going to put both. I'm going to say put it in vertex form, parentheses, standard form in your book. Okay? Just because I believe for a very long time, you've been taught that the top one was standard form. If you are confused on a test, which one I mean, ask me and I'll tell you. Okay? It's probably going to be vertex form is what I'm asking for on a test. Okay? So, this is vertex form of a parabola. Okay? You're going to look at this H right here, and you're going to look at that K right there. The H is opposite in value. The K is true to value. Okay? The H is opposite in value. The K is true to value. Okay, so it's like the circle, so don't miss that. Okay? Now, we're going to talk some about this A value. We didn't do any stretching or shrinking when we had that A value, but we did have positive and negative. So when that A value was negative, what was happening with my parabola? It was flipped, okay? It opened down, okay? So, we're going to write that right here. When A is positive, it's going to open up, okay? It looks like this, okay? When A is negative, it opens down. It's a reflection across the x-axis. Okay, and we did do reflections in chapter 2. Now, we are going to talk about stretching and shrinking. Now, I want you to visualize slope. Okay? And I want you to think about slope of a line that's like 1/4. Think about, and even draw a little picture on your graph or on your paper if you need to think about the slope being less than 1. And that could be, and I'm going to write it as absolute value of A. So that means I can have negative 1/4 or I can have positive 1/4. When the absolute value of A is less than 1. So right now we're talking about slope. What can you tell me about a line that has a slope of 1/4 or negative 1/4? Is it flat? Is it steep? Yeah, it's more flat. Okay? So if you've got a slope of 1/4 or negative 1/4, okay, you're going to have a flatter line. Okay? What that translates to here is you are going to have a wider parabola. You might also, parabola? I hope that's how you spell it. Okay, you're going to have a wider parabola. It's stretched out. Okay? We're pulling it further apart. Now, think about your slope as 4/1. 4/1. Okay, what is, yes, it's much what? It's much steeper, okay? Something similar is true here. So when my absolute value of A, and that just means it can be positive 4 or negative 4, okay, is greater than 1, you have a narrow parabola, and it's being pushed together, okay? So think about your fractions. If you've got a fraction it's going to be pulled apart. If you've got something greater than 1 or less than -1, it's going to be pushed together. Okay? Can I move off this screen? I know there's lots of good information. Can I move? Okay. This may be one that you want to take a picture of. Okay. Our green parabola is our original. Okay? The value is -1. So the absolute value of -1 is 1. So that's going to be kind of our standard right there. Okay? In our parent function, x squared, the a value is +1. So that's the width that we're kind of talking about when your a value is 1 or -1. Okay? My purple graph has an a value of -2, and it makes it more narrow. It makes it more narrow. Okay? So it's coming together. The -1/2 makes it wider. Okay? What's my vertex on that one? What's a vertex? Look at the formula. Don't look at the graph. Look at the formula. The -4 is the y value. I heard lots of people say -4 is the y value. 3 is the x value. So 3 -4 is it. Okay? 3 -4 is it. Okay? Okay. That is reasonable to take a picture of if you need to. Okay? Okay. Now, we're going to take the vertex formula, standard formula, which is f of x equals a times x minus h squared plus k. Now, I will give you that on the test. I will give you that on the test. Okay? And I am going to plug in a vertex of 2, 6. And then I want to do whatever I need to my a value to make it open down. Okay? To make it open down. So I'm going to go ahead and start with my a value. So I have f of x equals. What do I have to make my a value to make it open down? Negative. And I'm going to make it -1 because it doesn't tell me to shrink or stretch it. Okay? So it's just going to be -1. Okay? What's my h value? 2. It's 2. Okay? Now, it's +2 here, but it's x minus 2 here. Okay? Just like we do with a circle. And what's my k value? 6. Okay? Now, we're going to do another one. Got a vertex of -2, 2. It opens up, and I'm shrunk by a factor of 1/4. Okay? So, what's my a value? Yeah, I worry about that. It's actually 1/4. I'm not trying to trick you. Oh, I know. Shrunk and stretch are kind of used interchangeably. I actually believe that we stretch one when we've got a fraction, and we shrink it when we've got a number greater than 1. But I will tell you that it's that term's used interchangeably. But yeah, I'm with you. I'm totally with you. Okay? So my a value is 1/4. Okay? And then my x value, I've got x minus what? -2. Okay? So what does that become right there? Good. It's going to become positive. Okay? Then what's my h value? Good. Okay? Yes? You know, I did that same thing last class. Same exact thing. I forgot the squared. Thank you, Shay. Okay? Can I go on? Okay. Okay. This one's U. My vertex is 0, 3. Opens down. It's stretched by a factor of 7. Vertex 0, 3. Opens down. Stretched by a factor of 7. Okay, what is my A value? What's my A value here? Okay, I heard -7. What else did you guys say over here? Okay, 7. Okay, the answer is actually -7. Why? Because it opens down. Okay, so this right here, this opens down, and this stretched by a factor of 7, both apply to the A value. You're dealing with the A value right here. Okay, so between the two of these, we are able to determine that that A value is -7. Okay, then I have x minus 0 squared plus 3. Excellent. Okay, now I would probably leave it like that because it's asking us to put it in this form. If you got rid of that 0 and you wrote f of x equals -7x squared plus 3, I'm okay with that because you've simplified the 0, and I get it. Okay, so either one of those would be okay. Okay? Okay. Now, we are going to graph this. We're going to graph this. You are going to have to find 2 points in order to graph this. When I graph a line, I have to have at least 2 points. When I graph a parabola, I'm going to have to have at least 2 points. Okay? And you're going to be graphing parabolas inside WebAssign. And the graphing tool, it has a parabola shape. It kind of looks like that right there. The parabola tool. Okay, or the graphing tool, I'm sorry. So the first thing that we want to identify in this situation right here is the vertex. What's the vertex? 4 and -1. It's not 4. -4, thank you. -4, -1, that's my vertex. Is it opening up or opening down? Up, good, because I don't have anything in front of it. Okay, do I have a stretching and shrinking factor? No, it's just 1. Okay, I've got my vertex, -4, -1. 1, 2, 3, 4. So there's my vertex right there. Okay, now I must find another point. I have to have a second point. Okay, think about points on a line. How many points are on a line? Something that's linear. Infinitely many points. Okay, how many different x values that are there associated with those infinitely many points? Infinitely many. Okay, so if I had a linear equation, y equals 2x plus 4, what could I plug in for the x? When we do a table of values, what can I plug in? Anything I want. Okay? So, what we've got here is we've got to find a second point. So the way that we find a second point is we plug something in for x. We plug something in for x. Now, one of my very favorite numbers is 0 because it makes my life easier. So I almost always see if I can plug 0 in. Okay? So I'm going to do f of 0. That just means I'm plugging 0 in for x. 0 plus 4 squared minus 1. Okay? What's 0 plus 4? It's 4. What's 4 squared? 16 minus 1. 15. Okay, so this ordered pair right here is 0, comma 15. That's where I cross the y-axis, and I'm doing it way up here. Okay, so I might not want to use that point. Okay, it's completely reasonable to use that point, but you might not want to use that point. Okay? The other point that I would use is I would plug an x value in that's very close to your vertex. Okay? So I would find an x value that's either to the left or to the right, pretty close to the vertex. Okay? So what's this point right here? For the y, or I'm sorry, for the x. What's that? Yeah, it's negative 3. So we're going to find f of negative 3. F of negative 3. So I've got negative 3 plus 4 squared minus 1. Okay, what's negative 3 plus 4? 1. What's 1 squared?
1.
And then I've got 1 minus 1. So it's 0. So we kind of accidentally found, what did we find accidentally? Kind of accidentally. What did we find? I'm going to put the point there, and I bet you'll see. We've already got the vertex. What did I find with the second point? An x-intercept. An x-intercept. Kind of accidentally. We set out to find a second point, and we found... Then once you've got that second point, you can graph much better than I. Okay? So you are going to have 2 points in order to graph. Ooh, I gotta hurry. You're going to have two points in order to graph. Okay. Can I go to the next one? I'm gonna... Yeah, I want to do this one. Okay? For this one, I've got f of x equals 1/4 times x minus 6 squared minus 4. So the first thing I need is my vertex. What is my vertex here? 6, negative 4. Good. Okay, so I go over 6 and down 4. Whoa, 1, 2, 3, 4, 5, 6. Okay, so there's my vertex right there. Okay, now, here's a trick. What's the denominator on that fraction? 4, okay? The way to avoid having a fraction that you've got to graph is you make sure whatever you get right here is a multiple of 4, okay? And the reason I picked 4, multiple of 4, is because of this denominator right here, okay? So a multiple of 4 is 4, correct? Is 4 a multiple of 4? What's 1/4 of 4? 1, okay? Is 8 a multiple of 4? Yes. What's 1/4 of 8? 2. 16 is a multiple of 4. What's 1/4 of 16? 4. Okay? So if whatever you put in for that x value, and then you square it, you get a multiple of 4, it's going to be easier on you. Okay? And again, you definitely could do the y-intercept. You could plug 0 in. It's not a problem. And actually, I think the y-intercept gives us a somewhat reasonable answer. So let's do f of 0. So f of 0 equals 1/4 0 minus 6 squared minus 4. What's 0 minus 6? Negative 6. What's negative 6 squared? 36. So then I have 1/4 of positive 36 minus 4. Now, 1/4 of 36, you can just divide 36 by 4. What do I get? 9. And 9 minus 4 is 5. Okay, so that works. Right there. Okay? Now, I could also do probably 2, the number 2. Okay? Or I could do the number 4. Okay? I could plug in 4. So let's go ahead and do f of 4. No, let's do f of 2. I changed my mind. I know. I can't keep up. Okay? So 2, so I've got 1/4, 2 minus 6 squared minus 4. Okay? What's 2 minus 6? Negative 4. What's negative 4 squared? 16. What is 1/4 of 16? Oh man, I messed that up. That's not what I meant to do. Okay? 1/4 of 16 is 4. 4 minus 4 is 0. So our other point is 0. It's 2, 0. Okay, so again, we accidentally found an intercept. Oh man, I want points for that one. That one doesn't look too bad. It doesn't look fabulous, but it doesn't look too bad. Okay? So you've got to find a second point. You've got to find a second point. Okay? Now, this next part is the part that I want you to be sure you attempt some this weekend. I want you to get frustrated with it. I want you to watch the video again over this part. I want you to try some homework problems. The more you expose yourself to this next part, the better chance you have of it clicking when we do it again on Tuesday. So I'm going to show you the first example of it today. I want you to try some. Then on Tuesday, I'm going to show you a lot more examples. So the more work and the more you look at it this weekend, the better off you're going to be on Tuesday. In that video I sent out on Tuesday when we had the flooding, that's the same stuff. So if you watch that video and then you come back and you see it again on Tuesday, it's going to click. The more you see it, the better it is and it clicks. So what I am looking at right here is a parabola. I'm looking for a parabola. I want to solve this parabola for solutions, x-intercepts, roots, okay? I want to solve it, okay? The first thing that I'm going to do when I solve it, what do I have to set it equal to? 0. So I'm going to have x squared plus 4x plus 1 is equal to 0. Okay? So in order to solve it, I am going to set it equal to 0. Now, there are 3 ways I can solve quadratics. There are 3 ways that I can solve quadratics. Anybody remember any of them? Factor, okay? And I always factor first. Shay? Complete the square, and there's one more. Quadratic. Okay, and it's the quadratic formula. The quadratic formula. What I'm going to focus on right now is this method right here. Complete the square. I'm going to focus on completing the square. Okay? So, in order to complete the square here, I've got it set equal to 0, because you got to set it equal to 0 just to figure out what you want to do. You got to set it equal to 0. Okay? Then, my next step, okay, this is ax squared plus bx plus c. C is a constant. Okay, C is a constant. I'm going to move constant to opposite side of the equal sign. Okay? How do I do that? What do I get when I move that over? -1. Good. Okay, so this is x squared plus 4x equals -1. Okay? So I've moved that constant over. Okay. Now, I'm going to take 1/2 of my b value. I'm going to take 1/2 of my b value. I'm going to square that and then add to both sides. Okay? What is my b value? That's the first thing. What's my b value? 4. 4 is my b value. What's half of 4?
2.
And what's 2 squared? 4. So that's step number 3. I take half of my b value, I square it, and I add it to both sides. Half of 4 is 2. 2 squared is 4. And I add it to both sides. As long as I add it to both sides, have I kept my equation balanced? As long as I do it to both sides. Good. Okay. Then I have created what's called a perfect square trinomial on the left-hand side. So I am going to factor that side, and I'm going to simplify the other. Okay. So x squared plus 4x plus 4. A lot of students don't write this step down, and that's fine. What two numbers multiplied together give me 4? 2. Added together give me 4. 2 and 2. Okay? A lot of students know that this is going to be a perfect square trinomial, and so they don't write that step right there. How else could I write this? Instead of x plus 2 times x plus 2, what could I write? Excellent. X plus 2 squared. Now, x plus 2 squared equals 3. I'm completing the square. What's my next step in completing the square? What do I have to do? Say that again. Okay, I do, and in order to do that, what do I have to do to both sides? I've got to take the square root of both sides, and we are going to take the square root of both sides. Before we do that, on your paper, I want you to subtract 3 and move that 3 back over, and look at what you've done. Okay? Subtract 3, and instead of putting it equal to 0, put it equal to f of x. So you are subtracting 3 from both sides, and instead of it being equal to 0, because you've subtracted 3 from both sides, I want you to put f of x. What have you just done? Okay, it's always been a parabola.
Yeah, but now it's in the right form.
Okay, and what form is that? Yes. Okay, so we are going to use completing the square not only to find solutions of the and where it crosses the x-axis, you are also going to use it to turn it into the vertex formula. Okay, so we are able to use completing the square to turn it into the vertex formula. Okay, now we are going to do that, and I want you to see that at that step. But what I want us to do now is finish this. Okay, my next step is take the square root of both sides Okay, we're taking the square root of both sides. Okay, when I take the square root of 3, what do I have to do? What do I have to put in front of it? Plus or minus. Okay, so this is x plus 2 equals plus or minus the square root of 3. X plus 2 equals plus or minus the square root of 3. Okay? Last step. What am I isolating? Isolate the x. Okay? So I have x equals negative 2 plus or minus the square root of 3. Now remember, what we're finding here what we've found is about where it crosses the x-axis. That's what we found. And then we kind of accidentally also found what? The vertex. Okay, so our vertex was negative 2, negative 3. So our vertex is right here. Okay, now I know that you guys don't love that, completing the square, but it is what we're going to use to put things in vertex formula. It is what we're going to use to put things in vertex formula. Okay? Now, I'm going to erase this, then we're going to go through that process on how to do it to find the vertex formula. Okay? Is it okay for me to erase this? Okay. Okay, now I'm going to do new steps. These steps are for us to find vertex form. Our book also calls it standard. Okay. So, the first thing that we're going to do, we are going to keep our f of x. Okay, so we're going to keep our f of x. Okay, was it already in ax squared plus bx plus c? Okay, so you're going to start with the form ax squared plus bx plus c. You do want to do that. Okay, now my next step is going to be to separate the c value from the ax squared plus bx. Okay? We're going to separate that c value. Okay? We're not moving it to the other side. We are separating the c value. Okay? And this is how I'm going to do it, right here. Okay? I'm going to have x squared plus 4x. And then I'm going to have the plus 1 outside those parentheses. So I have separated the c value from the x squared plus 4x. Now on Tuesday, we're going to have problems where we have to do more stuff right here. Okay? But right now, we don't. So now I'm going to take half of b and square it. Okay, so I'm going to take half of b and square it, and I'm going to add that to inside the parentheses. Okay, so half of b is 2, and then I'm going to square it. So I get 4. Now, when we were completing the square, and that 1 was a negative 1, and it was on the other side, what did we add to the other side? I'm sorry? I added the plus 4. Good. That's exactly right. We aren't dealing with two sides of an equation. We're only dealing with one side of the equation. So I have inside the parentheses, and I have outside the parentheses. I've got to keep everything equal. So I have added a plus 4 inside the parentheses. I'm on the same side of the equation, so what do I have to do on the outside? Okay, it's not plus 4, because then I've just changed everything and I've gotten plus 8. I want it to be plus 0. Yes, I subtract 4, and that's where students make their mistakes, right there. So whatever I do in here, I do the opposite out here. Okay? So my step 4 is add the opposite outside the parentheses. Okay? I'm going to add the opposite outside the parentheses. That's where students get stuck. That's where when students get to that point right there, they don't know what to do next. You're keeping everything balanced. I added 4 on the inside. I subtract 4 on the outside. Okay? Now, I'm in good shape. Okay? So I factor my perfect square trinomial. We know that becomes x plus 2 squared. And then I've got minus 3. So my vertex is negative 2, negative 3. Okay, now we're going to add more numbers, and you're going to be asked to stretch and shrink, and you're going to be asked to factor a lot of those things out. So there's going to be a portion of that homework that you can't have done by Tuesday, which is the target date. I'm going to change that target date to Thursday. Okay, so that target date will change because of the floods and all that other kind of stuff. It is to your benefit to struggle with this section a little bit over the weekend. The more time you put into it over this weekend, the quicker it's going to click on Tuesday. Okay? Okay. Have a great weekend. I will see you guys on Tuesday.